Hey guys, I decided to make this video to make some clarification from yesterday discussion. I think maybe just looking at tables and graphics is not the best way to explain how it works on a spreadsheet. So I will just talk about my assumptions and the basic way that this spreadsheet works. So I took from U.S. Census Bureau 2010 population data from Kentucky and from vehicle register from the registration office of Kentucky. The ratio between people living in the state and the car ownership percentage, and I apply to the percentage of people living in apply this percentage to the people living in Lexington. Likewise, the motorcycle. So you can see that these values are from this, assuming this percentage of car ownership and motorcycle ownership. For the population projection worksheet, we can have both options. Yes, assuming like a growth rate, like a constant growth rate, or a growth rate year per year. So uh, the source of this growth rate applies specified for Lexington, Kentucky. I took it from Lexington, Kentucky government official page, so I think it's like a good source to for for calculate the population growth till 2030. So you can put whatever value here, and it's going to calculate. And in the same way, you can use it here, like on this growth rate. I can vary year per year if you want, so you can notice. You can put it whatever value year per year, and it's going to give me the population number. So after I found the projected population number, I'm going to apply carbon intensity, about what we talked about yesterday about improvement in technology, but not only technologies applied to the vehicles itself. It is applied to production procedures, to energy extraction, because I think we have to think on a vehicle not only the when you put gas on the vehicle or on the tailpipe emissions. You have to think about the whole process of making a vehicle. Is quite like a life cycle analysis. So I think these numbers are really related to that. And when I assume this percentage of reduction, I put it here. It can vary here, like minus, I say minus 1.9, and it calculates automatically the percentage of reduction that would be going to be applied to CO2 emission per year per unit per vehicle. So these values are going to apply to this one, and these values are represented here in this table, and it's going to 2030. So we can notice how, like, for example, SUVs on 2010 is like a 7.4 tons of CO2 emissions per year, but according to the improvements in technology, SUV is going to be in 2030 4.45, almost like it would be like this ratio, like almost minus 40% of the initial values. So the other assumption here is the vehicle distribution. We could modify this distribution per year in each one of the years that we are studying. So I think this is where our results. We're saying like, hey, if we are implementing this measure, we can reduce lighter vehicles like in 10% or SUVs. So I think that is a good way on giving quantifying data. Well, returning to this carbon intensity, so when I apply the macro, it's going to change all these values here, and is going to paste these values over here on this CO2 emission per year. So you can notice how it's varying according to that rate. These values are changing, and as a consequence of that, the emissions. And of course, this for each year that we are starting, I am applying the new population growth. So even though population is applying at the same time the carbon intensity reductions. That's why we obtain something like this as our business as usual this scenario. So if we didn't buy in like them, we don't have any changes on vehicle distribution, just doing nothing, emission is going to drop to this value. And as I read your request, she wants to to check here out these values without the assumption of any improvements in technology. So when we are going to us to make that assumption, we are doing the same distribution on vehicles, but these values never change through each one of the year we are going to study. So I let the same values for each year. So doing this, we are going to obtain this. It's going to be like 21% more emissions. It's not going like the previous, like on this, considering carbon intensity, that is going to be like this. So I think that's all, guys. Thank you.